So, good evening everyone. My name is Morgan. I'm a graduate engineer at AECOM. So I'm going to talk to you all tonight about segmental shafts, specifically looking at a few construction methods and water ingress, one of the key issues that can develop through the construction period. To give you an idea of what exactly a segmental shaft is, we have an example of a pumping station here. Now this is located in Bangor Marina Car Park. The picture on the left there that you can all see is the pumping station during construction. The picture on the right is what's left after we're finished. So there's very little left to see. In terms of how these are constructed, I'm going to try to use my crude model here. You've got a couple of intersecting segments, sort of the way you would build up using Lego. So these are like interlinked together and are built up to form the structure, to form the wall, as you can see here, as an example on site. Moving on to an alternate sort of example of a pumping station, we have one that was constructed last year in Bangor, another one Castle Park. There was two methods of construction used in this pumping station. The first method was actually sinking the shaft. So they started off this year by successfully constructing a beam around the outside of where the shaft would actually be constructed, where the segments would be used. Hydraulic jacks were then placed, all those red items that you can see there clearly on the screen, were set alongside, and these essentially pushed the segments down into the ground with all the excavated material being removed. During construction, the ground conditions slightly changed to what was expected, and we had to change technique to underpinning. This is slightly different. We reused the collar that the jacks were set on as a sort of ledge where the segments were connected into the sledge or at the top, and they were connected at the bottom rather than at the top as you have in the sinking methodology. So we can see a video here showing water ingress. Now, it doesn't quite work. You can see the water goes straight out of this here crude model because it's not being made watertight. Moving on to the next one. So water ingress is a big problem. There's two main reasons that we're sort of struggling with it now. You don't want water coming into your pumping station from the groundwater in the surrounding area. You don't want to be treating more than you need to be treating. Additionally, and especially in the cases of wastewater pumping stations, if water is getting out into the surrounding area, especially in aquifers, you don't want it contaminating the ground, especially potentially drinking water. There's two methods that contractors generally use to make sure they're watertight. The shafts are watertight. So one of them is pointing, so essentially sealing up the joints in between the segments through use of concrete grout or a resin. The other one is a liner, so you're essentially constructing a wall inside a wall. This will remove those joints and make it watertight. So, to summarise, there are a number of ways to actually construct these pumping stations, but it's always important to make them watertight. You don't want your water going where it doesn't need to go. Thank you for listening.
Conor Morgan, ladies and gentlemen. "85 seconds.
Conor, apologies in advance for the most shallow question of the night, but you were talking about water. Is it now compulsory for all young engineers to have beards?
It seems so. It seems so. There's plenty of them tonight.
Fiona's going to ask a more technical question.
I don't know now. I have to switch to a technical question. Is there another way to construct these? If it seems like there's a lot of problems.
There'll be a lot of problems, but it was just a problem in this here example.
Yeah.
So I used it because there was two methods of construction to show you. You could essentially dig out the ground, I suppose, and construct it from the bottom up in the ground like you would a building. But some of these here shafts are extremely deep. Like the example there that you can see here is, it's 14 metres to the foundation level. It would be very difficult to dig out a big hole and build it up the side. So the idea is to build it as you're going down, and that's sort of my thoughts on it anyway.
Conor, thanks. I suppose it could be a reinforced concrete structure.
It could be rectangular type.
So what would be the benefits of this over a reinforced concrete structure?
Well, you're getting into sort of the side of things, especially in wastewater, septicity. You don't want your dead areas in the corners where you can't properly clean it out very easily. A circular tank here, you don't have, because it's circular, you're able to clean it a lot easier. The client, when they're in water in this instance, prefers using these circular tanks for a start.
Can I not build a circular reinforced concrete pipe or tank?
You could, but it'd be more difficult and take longer. The way I see it is this is a precast structure. It's going to be more cost effective to be able to bring the segments to site, and it will be easier to construct. You'll have the jointing mechanisms in place. So, yeah.
And is there not a joint then in between the segments?
There'll be a hydrophilic strip now, but depending on what the groundwater is in the area, it still doesn't fully seal the structure at all times.
So what do you think? Do you think we maybe need more research on the joints?
Absolutely.
Yeah. Okay. Anybody looking to do a PhD? Okay, thank you.
Settled.
Any audience questions?
You can see in this example, there's a lot of water running down the inside of this tank.
So how do you make sure that doesn't happen in time, once you put the car park over the top?
Well, that's what I'm saying. You have to make sure that you're getting the jointing right, you're getting the sealant right. You carry out a water test. There is a specification using some year specification for the water industry that determines what is allowed in these here segmental structures before they're actually going to be filled in and covered over the top. Make sure it's watertight.
Conor Morgan, ladies and gentlemen, let's hear it for him.